Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, today I would like to present on logarithmic differentiation. So this is one of the topic that we have in the topic of 2.7. Okay, before this we have learned on exponential derivative and also exponential function derivative and also uh, logarithmic function derivative. Okay, so this is the third topic on this topic 2.7. Okay, all right, so how to apply this logarithmic differentiation? So there is three steps. So number one, you take the natural logarithm of both sides. Number two, simplify using properties of log. Number three, we'll differentiate both sides with respect to x. Okay, so I think maybe some of you wonder when is it you want to use this logarithmic differentiation. Okay, so before this, you might have seen, you might have known how to differentiate this one. Let's say you have y equals to x power 5. So how do you differentiate y equals to x power 5? So you should get y prime equals to 5x power of 4. Another one, let's say you have y equals to 5 power of x. Okay, this is example of exponential function. So how do you differentiate this? So you should get y prime equals to 5 power of x ln 5, right? Okay, how about if you have like this, y equals to x power of 5x. Okay, so what can you see here? If you compare from these three is, if the first one we have the variable at the base, and then the second one we have the variable as the power, but for the third one we have the variable at both the base and the power. Okay, so actually there is no formula to differentiate if you have both the base and the power in terms of variable. Okay, that's what the logarithmic differentiation come in. Is you have to apply the step that we will use just now. Okay, right. For example, let's say you have y equals to x power of x. Okay, x power of x. Right. So as you can see here, both the what we call the base and the power are in terms of variable. Okay. So what you need to do is first you add ln both sides. So you have ln y equals to ln x power of x. Okay. And then what you need to do after that is we apply properties of log, where we will bring x to the prime. So we have ln y equals to x ln x. Okay, so you can see here the use of this ln is to bring the power, the power into variable here to the prime. So right now we have x ln x. Okay, after that we can differentiate. Okay, so differentiate this, you get ln y equals to 1 over y dy dx equals to, differentiate this, because this one variable times variable, so you need to apply product rule. So 1 times ln x plus x times 1 over x. So cancel. So you left with dy dx equals to what? So you bring one y to the right side. So dy dx equals to y times ln x plus 1. Okay, and then don't forget to substitute back what is y. So here we'll have ln x power of x times ln x plus 1. Okay, this is the final answer for this example 1. Right, so you want the answer in terms of x. That's why you substitute the original question into y here. Okay. Next, example B. Let's say we have y equals to x squared plus 1 power of 2x. So again, as you can see here, both the base and also the power is in terms of variable. So what we need to do is first we add ln both sides. Okay, and then we bring 2x to the front. And then we can differentiate 1 over y dy dx equals to, so this one we have to apply product rule. So 2 times ln of x squared plus 1 plus 2x times 1 over x squared plus 1 times 2x. Okay, and then we simplify. So we may bring this 1 over y to the right side. So y times 2 ln of x squared plus 1 plus 4x squared over x squared plus 1. Okay, and then finally we substitute y is y. So y is ln of x squared plus 1 power of 2x times 2 ln x squared plus 1 plus 4x squared over x squared plus 1. Okay, alright, done. Okay, for the second one. Okay, I think the rest for questions C and D, example 1, you can try on your own. Okay, from the book there. It's similar to the example that we have shown here.